All right, well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of it, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar and on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, you can just use your questions tab, the Q&A tab in the middle of the interface and submit your questions. And we will try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is protecting cloud-native apps and APIs in Kubernetes. Our speakers today are Stepan Ilian, who is the co-founder of WallArm, and Victor Gartvich, who is a VP of Security Solutions at WallArm. Victor's not on camera right now, but he is here. Gentlemen, thank you both for joining me today. Really appreciate it.
Thanks for having us.
Great. So Stepan, I know you're going to be kicking off the conversation. I'm going to take myself off camera, put myself on mute, and let you get right into your presentation.
Sounds good. Okay, let me switch to the slides.
We can see your screen, Stepan.
Yeah, I just need to switch to another tab. Okay, I made it. That wasn't easy. All those new platforms for webinars. So thanks again for joining, guys. We'll talk about the cloud-native security and particularly about the protection of APIs and apps, and specifically in Kubernetes environments. So a lot of those things actually pretty applicable if you're not in Kubernetes yet. But the idea is basically to show you that there are a lot of tools out there, including open source tools that you can basically take right away and use to protect your apps, APIs, wherever you're running them right now, like in the private data centers, public clouds, or in Kubernetes. And from our experience, a lot of companies are moving to Kubernetes really quickly right now. So it's a good positive signal for us. But we just want to share with you a couple of things that can be really relevant to you when you think about the securing of those assets. I would say that there will be 2 parts of this presentation. First, we'll talk a lot about the open source tools and basically how to choose WAF, how to set up different kind of visibility into the malicious traffic, how to set up alerts, how to fight bots, what kind of traffic you can block. All those things are very practical, and this would be like a very condensed webinar. There will be a lot of content out there, so stay tuned. The second part, we'll talk more about the WallArm because we have our own view of the problem and how you can solve the API security protection in your cloud native environment. So, and of course, at the very end, we can answer all the questions that you probably will have. But let's start with the API and microservice security. So, when we think and when we talk about the threats, we obviously think about the things like OWASP Top 10 or OWASP API Security Top 10. Apparently, not everybody knows that, but there is the dedicated OWASP for API threats currently. So you need to protect all those assets. And obviously, when we speak about the SQL injections, XXC, and so forth, are one of the top tools that we have in mind. It's WAF. And I bet a lot of you already have some kind of experience with WAF. So the question here is, what WAF to take and what WAF can you use in the Kubernetes? So, and we'll talk about this today a lot. So for all of you who already use Kubernetes, you are probably familiar with the term Ingress. So basically, what is cool is that for the Kubernetes environment, there are plenty of the Ingress controllers. And one of the most popular is basically based on the NGINX. So you can think of it as a API gateway that's specifically built for the API so that you can manage the traffic flow to all the services and pods. So the good thing that the default Ingress controller, which is a part of the Kubernetes ecosystem, is basically based on the NGINX. So NGINX with us for a long, long time. So we have a lot of tooling that is already built for the NGINX. And it means that you can actually use all those techniques, all those tools with the NGINX Ingress controller in the Kubernetes environment. So one of the things, and I will talk more about that, is that NGINX Ingress controller actually comes with the ModSecurity built in, so you can use ModSecurity, which is one of the most popular WAFs out of there, primarily because it's open source. So a lot of you already had NGINX in environments, so you know that you can plug in a lot of modules, including WAF. So the very same thing you can do with the Kubernetes. So as I've said, you can take the Ingress controller. It is based on the NGINX. You can turn on WAF there, and you will get protection. You will get the traffic analysis for all those services that you're running in your Kubernetes. Another way of deployment, and we will talk more about that, I will just quickly mention it right now, that you can actually deploy the so-called sidecar container. So this is basically the container that would be running within every application pod you have. It will get all the requests that come into the application container first, apply some kind of analysis. So if this analysis includes WAF, like all the requests for this application within this pod will be analyzed with the WAF, which is also a great way to deploy a WAF, especially if you want to give flexibility to your teams if they want to use it or not to use. So this is actually very good. Speaking about the WAFs for Kubernetes, I want to mention two products. So one is ModSecurity. We talked about this. Like, this is the open source WAF, and this is probably the only open source WAF that you actually can use nowadays. Like, it has a great community. It is very customizable, and there are a lot of things out there that you will like. It comes with a lot of limitations as well, because it's only WAF. There are no real API protection. It can't parse JSON, XML, GraphQL. You need to tune it manually. But at the very same day, you can use it pretty effectively, especially if you have somebody who can actually work with ModSecurity on the day-to-day basis. This is a great tool, and I highly recommend to try it out. There are a number of the commercial products out there. So we represent Wallarm. And we believe this is the very best solution on the market, but there are some others, and we'll talk more about this and like how it's comparable with the ModSecurity. So let's start with the ModSecurity. So there would be a need to make like at least one webinar specifically on the ModSecurity, because it's so great tool and there are so many capabilities out there. But basically, what you need to know is that it's open source. You can use it free of charge. It can be pretty efficient in detecting a lot of OWASP Top 10 kind of threats. It supports virtual patching, and there are a lot of resources out there, including this book by Ivan Ristich about how to basically tune the ModSecurity. So the idea is very simple. It's basically, there is a library of the signatures. It's regular expressions that describes different kind of attacks, different kind of CVEs, different kind of types of attacks like SQL injection, so forth. So you always have this library of rules that looks like this regular expressions. Like, this is an example of our virtual patch for the shell shock vulnerability like this. So basically it says, hey, I want to look for this particular regular expression in the headers. And if there is something like that in the request, I want this to be considered an attack. A lot of times these rules get really, really messy. So this is just the example of the rule to identify SQL injection. So unfortunately, when you work within ModSecurity, you need to deal with this kind of complexity. And this is why I'm saying that usually our successful use of ModSecurity requires somebody in the team who will be really into tuning this. But apparently this is a very powerful thing that you can start using right away. Some things that keep in mind is basically false positives. If you turn on ModSecurity, wait for going to the blocking mode, because you will have a lot of false positives. You need a lot of tuning to make it work. it is based on the signatures, so you need to be sure that you update all those signatures all the time. And one of the most important things is basically if you have the app that is frequently updated, you have a lot of updates and a lot of changes in the business logic, you need to tune those rules every time, because if you have a major update, you can have false positives again. So like this is a continuous process. One of the kind of best practices I like to recommend using ModSecurity is that you actually need to minimize the number of rules. So you basically can have a pair of rules that would, from one hand, analyze the request and then analyze the response. And if there is a match, you can actually trigger those things. And you can minimize the number of rules, but make it really meaningful and make it really something that you can actually maintain. So this is an example of the rule with the payload like a TC password, and then we can analyze the response and look for something like root, something that everybody of you know as the first line of ATC password. So this is something that you actually can maintain, and this can be a great thing, but once again, you need to tune the thing, and this is the topic for a separate webinar. So speaking about how to use in the Kubernetes, it's pretty simple, because usually what you need to do is go to the NGINX configuration file and use this directive to turn ModSecurity. In Kubernetes, you just need to change the config map. So you basically need to find the flag, enable ModSecurity and turn it into the true, and also turn on some of the core rule sets. So it's that simple. I include this and we'll share the presentation so you can basically use and copy paste it, but it's fairly easy. Once you have it set up and turned on, you can send a test request to your web application or API, and as a result, you will see the 403. 403 means that the request was blocked. It means that there was some kind of payload. In this particular case, it's a SQL injection. ModSecurity, being a part of the Ingress controller, analyze this request, identify this SQL injection payload, and it blocked the request. So like it's very, very easy. WAF, it's hard to use WAF just on its own. So you need to think how to make WAF a part of your workflow, a part of your procedure, a part of something that your team works on day-to-day basis. So one of the things we can do right away, and like I will give you some insights about that, is to build a security dashboard, and then set up alerts when something wrong is happening, so that you are aware that something is going wrong and requires your attention. Like the good thing is that we again can use we can use a lot of open source tools. Now, I bet you are familiar with a lot of them, like FluentD, ElasticSearch, Kibana, and some others you probably are not familiar with, but we will talk something like Elast Alert. So the idea is very simple, actually. We want to analyze all the traffic with the Ingress controller, with the ModSecurity. This ModSecurity will send events with the FluentD into the ElasticSearch. So we will index all the events there. With the Kibana, we will create the dashboard, and then we will use the Elast Alert tool to send the different kind of alerts and notifications to different kind of tools that you already have, like Slack or PagerDuty and so forth. So let's unpack it. The way it works is very, very simple. So on Ingress controller, we will store all the logs in a dedicated file, like let's call it audit log. Then FluentD parses all those logs, and it sends all the logs to Elasticsearch. So think of it as a kind of proxy, so that will simplify the whole thing. Get all the logs and send it to Elasticsearch. Then we will visualize all the logs with Kibana. I bet you tried it. If you haven't tried it, like highly recommended to try it right away. Like there are a lot of other use cases for that. And once we have all the data in Elasticsearch, we will use the special tool developed by Yelp that will get some kind of results and use this results to send the alerts with the different kind of parameters to your Slack or other tooling. So what's next? We can run the FluentD as a sidecar in the Ingress and NGINX pod. And one of the things that you also need to do is basically share the a volume between Ingress and NGINX and FluentD, so that the FluentD can access those ModSecurity logs. This is pretty simple. So once again, this is the example that you can use right away to set up the fluentd ModSecurity. So you need to specify host, username, and password for ElasticSearch. And as a result of it, you will have all the events in your ElasticSearch. So this is already great because you have visibility. You don't need anymore to go to the log files and try to read it. You now have it in Elasticsearch. You can look for different kind of data. You can search. You can investigate. You can run different kind of forensic procedures there, which is pretty much awesome. Unfortunately, ModSecurity is it provides a lot of capabilities. Still, it's pretty limited in what it can do, especially if we are talking about protection of APIs and microservices. So you won't get this granular and the really detailed insights. What API endpoint was affected? What was the structure like? And especially unfortunate that ModSecurity doesn't really parse JSON and XML. So there would be some limitations there. But anyway, you will have some visibility, and it would be much more searchable with Elasticsearch. One of the things that I like about Elasticsearch is that you also have Kibana, so you can set up different kind of dashboards. For instance, have the graph of all the traffic, and then you have a graph of all the malicious requests, and you can do the breakdown by different applications. So basically, it's super customizable, and you can set up different kind of dashboards that would fit your particular tasks, and so forth. Having another dashboard is cool, right? And you can put another TV in your office. I mean, I am not sure that anyone have an office now, but anyway, having another dashboard is cool and not cool at the very same time, right? Nobody wants another dashboard to look at. Everybody wants integrate all of the tooling you have right now, in a kind of one unified workflow, especially if it can be used by the DevOps team, ops team, developers, security operations, and so forth. So one of the things I found really helpful to make all those guys and girls to work together is to set up proper alerting. So there's a great tool, I mentioned it already, ElastAlert, developed by Yelp team. So what it is basically a simple framework that can alert you on different kind of anomalies, spikes in the attacks of traffic, and basically react to different kind of patterns of interest from the data that you already store in Elasticsearch. So if you can see data in Elasticsearch in Kibana, ElastAlert can alert that. So this is really, really awesome. It's open source tool. You can go and look for all the docs there. But basically, I want just to give you some kind of examples of what you can do. So you can look and set up different kind of events, and you can look for the number of events, or you can look for spikes, and you can set up the rules like, if there is a match where there are at least X events in the Y time, I want to know about that. Or I want to know when the rate of the events increases or decreases, and you can set up something, hey, if the rate of the SQL injections for this particular application is increasing really, really rapidly, I want to send the message to my Slack and to make my team know about that. Something like that. Here are some other examples. So as you can see, it's super flexible. So you can look for different kind of events and use the declarative way of showing this, like the example on the left side, the spike, the height of the spike, the time frame, the threshold. So you can use this. What's also awesome is that there are a lot of connectors that are ready to use out of the box. You can send alert to Jira, or you can send a message to Slack, or you can notify your team with a SMS with Twilio, or you can set up for incident response procedure in PagerDuty or Opsgenie. So everything you have in place already is properly supported by ElastAlert. So awesome tool. I like it. This is another example of how to set the whole thing up. As you can see, Everything is in declarative way, and pretty understandable. So no need to go through all those settings here. I basically set up what I want to know, what message I want to send to what channel. Like in this particular case, we will send the message into the Slack, specify the username, subject, what would be included into the message, and as a result, we will have this message in our Slack channel. I like it. Switching the gears. So we have this dashboard, we have these alerts in place, we have all the traffic analyzed for OWASP top 10 things like SQL injections, XXC, different kind of CVEs. We set up virtual patches. So what's next? Next is another topic, is how to protect all those apps you have against bots and different kind of behavioral-based attacks. You, once again, have a lot of tools out there that were initially built for the NGINX, but once again, you can use them with the Ingress controller. And cool that you actually can protect against some of the L7 DDoS attacks. You can identify site scrappers, you can identify brute force attempts, and and basically bots. And this is a hard topic. Like, I don't want to give you a false idea that you can effectively block with everything out there. You can't. Like, you need to specify dedicated solutions for that, like WAFs or API security solutions, bot mitigations products. Some of them are pretty expensive, but you can do a lot of stuff by yourself to at least block like the most basic stuff and like less basic. And in most cases, this will already give you a result. And what we see a lot across the market is that you have APIs, you have apps, and if you don't have any protection in place, there will be a lot of attackers that will simply run the very simple Python script or a bash script and like will abuse all the logic of your application and scrap and run the credential stuff in a text. But once you have something there, like it really increases the resources that should be invested to implement the attack, and like it already gives a lot of value. So don't undervalue the things that you can do right now. So like this is really, really helpful. So one of the first tips is basically what kind of traffic you can block by default, right? You don't need all the traffic. You need the traffic from your customers, from your users. And there are some things, some situations when you actually can make an assumption. Hey, I don't think that my users actually come from the data centers or from hosting providers. Like, it looks weird. Or why they are using Tor. You can block some of the some of the traffic. And the good idea is basically to think, hey, what traffic I can actually block? And a lot of people like to block traffic from some certain countries, especially to meet some compliance, and they also basically to block if you serve the customers from the US, like it's no need to get everybody allowed to visit the website. This is the logic behind like that a lot of people follow. I am not a great fan of using this particular practice because GeoIP data is not actually accurate, and you can block the real users. But in some situations, this can be very, very efficient. So once again, the NGINX has this impressive GeoIP module, and it can be used to block the requests coming from the countries that you don't really want to visit your websites or access your applications. What else can you block? So Tor exit nodes, right? Like if you don't want the traffic from Tor, the list of all the exit nodes of Tor is available publicly. So you can go to this checktorproject.org exit addresses and basically block everything that is out there, like do it very quickly. A lot of providers like MaxMind, but there are plenty of others, provide different lists of proxies, anonymizers, and other suspicious IP addresses. So we can subscribe for that feeds and use that in your protection. They are paid, but in many cases, they are not super expensive. I mean, they are not crazy expensive, and a lot of companies can actually afford it. There are a lot of lists with the malicious IPs, are especially made by the different kind of honeypots companies. So the idea is very simple. They set up different kind of honeypots like WordPress vulnerable instances, and basically see what kind of IPs are trying to exploit it. Like what kind of IPs are trying to brute force passwords, what kind of IPs are trying to, I don't know, basically look for WordPresses across the globe. They have up-to-date lists. Again, nobody can guarantee that those IPs and list of IPs are super accurate, but like in many cases, and we matches those data with the data that we see across our customers. Like there are a lot of matches out there, and they so in some particular cases it can be pretty efficient. And as a result, you can block some countries, you can block Tor, you can block proxies, you can block this IP malicious IP lists. What else can you block is the data from the data centers. I mean, it's a very rare situation when somebody is coming from Google Cloud, right? It means that there is a proxy there, or there is a script that is running the data center. So I'm not advising for everyone to use this, but for some of you guys, it can be pretty helpful. So all those cloud providers, they give you the feeds of the IP addresses, so you can Google for that, like for the GCP, AWS, Azure. On the right side of the screen, you see this summary of the subsets, network subsets for Amazon. But basically, you can Google for the IP ranges for pretty much any provider out there and block all the traffic from the data centers. Switching to the gears to the next one, like bots. How to detect bots. And this is a very hard topic, and basically, especially now, when there are more and more bots that are what we called full browser stack bots, when they actually are not curl command anymore, and they actually are running on the real machines, and they open the real browser, and they go from the real browser to the website or a login form and implement all those attacks. It is insanely hard to block all those bots, like a disclaimer. And I don't want to discourage you from doing anything, but like this is a really hard thing to implement, especially on your own when you don't have a dedicated security solution. But you can do a lot of stuff, actually. So one of the things is basically to use the modules that can run different kind of checks against the bots. And as I've said, still there are a lot of bots out there that are very basic. And what you can do is basically check if the client supports cookies, or if the client can perform HTTP redirect, or if the client supports JavaScript. We have this point here. If the client supports /, I don't think that you need to do this check anymore. But this module test cookie is something that is available open source. You can easily plug it into your environment, into the NGINX Ingress controller, and run these checks and identify a lot of tooling that is not passing all these checks. And you can go to the docs of this project. You will see a lot of details of like what kind of challenges it gives to the client to check if it supports JavaScript and so forth. But the idea is very simple, right? Like you just give the task to the client that's supposed to be executed with the JavaScript on the client side. And if the client doesn't do that, like it means it doesn't support JavaScript. And no real user doesn't support. No real users don't support. No real users, support the browser, have a browser but doesn't support JavaScript. So it's a very strong signal that this is a bot and you need to block it. So there are pros and cons of this. Like you can block a lot of bots out there, but be aware. And I want you to know, especially to be friends with your marketing team, is that by blocking bots, you need to be sure that you are not blocking good bots like Google bots and other search engines and so forth. So please keep that in mind. And once again, if we speak about more sophisticated attackers that are using the bots with a full browser stack, this particular method wouldn't be efficient enough. Next thing, And I promise to be fast, right? So this is a fast thing. Like we want to cover as much as we can, but we're almost there, I promise. So Fingerprint.js. This is an amazing library. Basically, it can fingerprint the users and they identify if somebody is trying to violate your particular application and try to do it with the username of other customer, or it creates more and more users, and it still has the very same fingerprint. So there is an amazing library. It's open source. There is also a commercial version of this library right now, but it's still open source. You can go to the GitHub and get more details about that, but the idea is very simple. It actually creates the unique ID for every particular browser it has without using cookies. I mean, unfortunately, our browsers expose a lot of data. Even if you don't have cookies in place, there are like dozens and dozens of techniques how we can fingerprint you. And we can take a look at the number of video codecs that your system supports, or what kind of fonts you have in place, or what kind of languages you support out there, and like a lot of other things. So this is techniques that are used heavily by the big companies like Twitter, Salesforce, or LinkedIn. So they do a lot of stuff to identify all those malicious actors by using this fingerprinting. And the good thing that is actually a lot of those techniques are actually open source, and they are available as a part of this library, Fingerprint.js. So we can go there, try to download it and use it. You don't actually need even the Ingress controller for that because it's JavaScript, but you can identify all those situations where somebody registered twice or uses multiple credit cards or multiple accounts or pretty much any other malicious activity. So this is really good. One thing that is not specifically protecting you against something, but we found very efficient working, especially being a part of the larger company, because sometimes it's hard to come to the DevOps team and say, hey, we need to install another security product, or we need to add another protection layer, or we need to do something else that would be in line, like in line of your traffic. And obviously, any team that is responsible for the SLA and basically for availability of your apps and APIs would be worried, like, hey, I don't want anything in line. Like, I'm afraid this thing, like if it breaks, it will break the whole production. So is there any safe way to plug in security there? And you need to have an answer to that. So one of the answers is basically provide them with an option. Hey, let's start and run our experiment in a non-blocking way and even not in line. What if we can take the copy of all the traffic and apply all of our analysis there? So the good thing is that with the NGINX and Ingress controller, you actually can mirror the traffic in an async mode to the additional endpoint, so like additional backend, sorry. So the idea is very simple. You get the request to the Ingress controller, and this request goes as usual to the usual backend. But the copy of the request also goes to another backend where we can do like different kind of analysis. For instance, you can deploy WAF there. And in this particular case, you can analyze all the traffic there on additional backend. And that would be really, really awesome, because in this particular case, like everything will be the very same as it was to be, like it used to be, but you will also have visibility of what's going on. And yes, you won't be able to block any requests, but at least you will get all this visibility. So like this is not the ideal option, but we found that this particular technique actually pretty powerful if you want to run POCs for products, or you want to POC some kind of technique that your house made, and so forth. So like just keep in mind that it's an option for that, and NGINX supports this directive. And by NGINX, I also mean the NGINX Ingress controller. It supports the mirror directive, and you actually can direct and mirror all the traffic to additional backend. We talked a lot about the open source tools, and it's amazing how much you can implement and achieve with only using the open source tools. Yes, you need to cook it, and you need to know what kind of combinations to use. You need to deal with the tuning and so forth. For those of you who don't have capacity of the team to tune all those things, who want to have a product with the support, who wants to have the proper API protection, I encourage you to try WallArm, because we basically implemented a lot of things that we've talked before that was able with the open source tools, but created much more in terms of the visibility, protection, API protection, alerting, integrations, and basically analysis, and even automating the incident response. And one of the important things that we always try to mention and to emphasize to our customers that the world changed. Yes, we are not protecting applications anymore. We're primarily protecting APIs and microservices. And basically, if you take a look at the traffic, 83% of all the web traffic are API calls. And APIs already became the primary target for the attackers. So when you are looking for API security, open source or not open source, you need to ask questions like if it's able to provide the protection for your APIs. So speaking about the WallArm, we have different ways of describing ourselves, but I just want to emphasize a few things here. So first, we can protect everything. So it can be apps, it can be APIs, it can be microservices. They can be run anywhere in private data centers, in public clouds, multi-clouds. It can be run in Kubernetes environments. We can protect all those cases against OWASP Top 10 and against the API-specific threats. We can help you to respond. So we'll give you full visibility of what's going on with the traffic. We can help you to set up different kind of alerts and send the traffic to the Slack, PagerDuty, Opsgenie, or set up integrations with the webhooks or whatever else. We can help you to discover what you actually need to protect, like all the apps and APIs. Identify the API structure based on the traffic. You can actually compare it with what you have in your docs and the Swagger and what you have in your traffic. I bet there are a lot of differences there, by the way. So this is what a usual thing there. And we also have a testing product that can actually automate the API security testing, being a part of your CI pipelines. And of course, everything is cloud native. So it's ready to use in your Kubernetes environments. One of the major three things are when we describe us is basically cloud native next-gen WAF to protect all your applications, API threat protection module to protect your APIs, and app exposure is basically identify and scan everything that you have exposed to find vulnerabilities, because you need to constantly assess what you have out there. WAF at the very end or any other defensive techniques are not helping you to identify issues. So we try to make sure that we actually can not only protect, but also assess all of the assets, APIs, apps, services, some kind of old, outdated products you have, and find the vulnerabilities. And we do a great job of making this happen. I won't give you the full product overview, please go to the website and sign up for the product demo, or at least go to our webinar. But one of the things I want to show you is basically the architecture that we have, because all the traffic we analyze with the so-called WallArm nodes, and you can actually deploy them in any environment. It can be Kubernetes, it can be service mesh, it can be just Docker containers in your environment where you don't have Kubernetes. You can deploy it in multiple clouds, or you can deploy it as a module for the load balancer like NGINX. So all the traffic will be analyzed in your infrastructure. However, you will have all the power of our cloud engine, and here a lot of analytics, automated threat protection, automated incident response. You can search, you will have a lot of dashboards, you can set up different kind of alerts and integrations with the other tools that you have. And basically, speaking about the deployment options, I don't want to speak about all of those things, but you have the option of deploying it into the Kubernetes environments. And actually, if you don't want to deploy anything in your environment, you can also use the cloud version of the product where we actually can analyze all the traffic. But in this particular case, we can only protect your age, like something that is exposed. In this particular case, we can also analyze not only the traffic that is coming from outside, but also the traffic between your microservices. If you're going to this zero trust kind of are seeing the world, this is something that would be very helpful for you, because in this particular case, you can protect every particular API or microservice that you have in your infrastructure. And obviously, I mentioned that we are really focused about the APIs. So we always supported SOAP and REST. We can parse XML and JSON, all the nested structures. And lately, last year, we added the support for the gRPC and GraphQL. So whatever stack you're using, we're committed to protect it, especially because we have this API request inspection when we actually can analyze the request without actually knowing what's inside. So you don't need to upload any schema. We will take the request, we will identify, okay, this is JSON, we need to apply JSON parser, we will have the full structure. If we see that there is a nested format like base64, we will apply the chain of parsers, like we'll apply the base64. So the idea is basically to see really deep and look for malicious behavior everywhere within the request. And as I mentioned already, we actually can give you the view of how your application works. It's available there. Don't look at this beta in Q3. It's an old slide. It was in beta in Q3. Now it's available, so you can like sign up and you see the whole thing, see and have full visibility what you have in the traffic. And on this note, I want to pass the baton to my colleague Victor, who will actually show you a demo with the Kubernetes. Victor.
Thank you so much, Stepan. Any chance you can stop screen sharing so I can start on my end?
Yeah, I think you can do that.
Okay, so let me do the screen sharing. Okay, can you see my screen? Stepan, can you see my screen? Just
I don't see the screen so far.
Stop sharing. So I got a note that my screen sharing was disconnected.
Try again. All those new platforms.
Okay, I'm trying again. Stepan, can you see my screen?
Yes, I can see it now. It's loading, so I think, yeah, I see the console.
Fantastic, thank you so much. So I will show our ability to protect Kubernetes clusters from different angles. I will show you the Kubernetes Ingress controller side, and also ability to integrate with application pods as sidecar containers. And with this our demo Kubernetes cluster, here is a list of Helm charts deployed in the system. You can see there is a Valarm Ingress controller chart deployed. You can take a look at the list of deployed containers and search for Ingress controllers, and you will see a list of 4 containers. So with our primary Ingress controller container doing the actual filtering, there is an additional pod doing our post-analytic functionality, and with this default Ingress controller as a default backend server. You can also see that the cluster is running Istio, our Ingress controller can easily work in Istio-enabled Kubernetes clusters, which is just an example of Istio egress controller running in the system. In order to utilize, in order to associate an application with Ingress controller, you need to use Ingress objects. And here is a list of Ingress objects configured in the demo cluster. And you can see some of them have only port HTTP enabled. For some, we have HTTPS enabled as well. Let's take one Ingress controller as an example, and do get Ingress and take a look at the configuration of the Ingress controller. You can see some Valarm specific annotations, and you can see some generic annotations. Like this one, control defines the name of Ingress class or disables SSL redirect. And here you can see controls provided by Valarm. You can set the application instance for the Ingress object, and also you can manage Valarm mode. And you can see that the specific application is using one of the application backends, and it also has TLS support enabled. Our Ingress controller is a plug-and-play replacement for community NGINX Ingress controller. Can be easily integrated with different SSL certificate management systems. Like in this class, in this case, we have Cert Manager, pretty popular manager used for Let's Encrypt certificates. And it will automatically provision certificates for domains pointing to the same cluster. Like in this example, as you can see, there are 4 SSL certificates. And we can take a look at the logs. I use utility kubetail to take a look at the Ingress controller. So it will read logs from pods and all containers inside the pods, and you can see some requests in our demo environment. So the system will report on the console. Let me stop the output and switch to a browser to demonstrate you our documentation. On our documentation website, docs.valarm.com, in the administration guide and installation section, you can find information about how to deploy our platform in a variety of platforms, but for now, we'll focus on the Kubernetes section. Here is a pretty detailed step-by-step instruction how to integrate our Kubernetes Ingress controller inside the Kubernetes cluster. You just need to follow the process and execute the commands. And to simplify your life, we even provided open source code for Terraform configuration we use to manage our own Kubernetes clusters. Like here, you can see Terraform code used to deploy Helm chart in our test Kubernetes cluster. And we also highlight different fine-tunings we recommend to perform on a deployed Kubernetes cluster. For example, a configuration of proper reporting of end-user IP address. When we see requests passing through one or more stages of load balancers, for example, in a cloud environment, it's important to make sure that the end-user IP address is correctly passed through TCP connections or through x44 similar headers inside HTTP requests. Or another section about enabling or disabling access control lists or blacklisting in ACL configuration. There is a page about high availability considerations and also a page about how to enable monitoring of your Ingress controller using a Prometheus monitoring system. There is another page in the Kubernetes section focused on deployment of Valarm WAF protection in Kubernetes cluster using a sidecar container. Let me click on a page about explaining how it works. Technically, there is one workflow without added sidecar container when the request through the cluster IP service inside Kubernetes cluster will hit directly container in the application pod. And when we integrate Valarm sidecar container, we redirect the request from the cluster IP service to go first to the sidecar container of Valarm. And after that, for safe request, they will be redirected locally to the application. And we also provide step-by-step instructions for 2 most popular integrations for applications running in Kubernetes. One through a Helm chart, and here is instructions how you can modify your existing Helm chart in order to attach Valarm Ingress Valarm sidecar container inside the existing chart. Or if you're using plain Kubernetes manifest, here's instructions how you can modify your manifest to add our sidecar. The 2 instructions are more or less similar. It's just a matter of placing the right information, the right files, and using proper variables when you pass configuration between modules. And now I switch back to the console and demonstrate you an actual example of a container running with a sidecar. With this then vulnerable WebSocket application, and with this container, I will do describe on the pod to see what's inside the pod. And here in the list of containers, you can see the application container with the application itself. And in the same pod, we have one more container with the Valarm WAF node. And in the way how it's configured to listen on 2 TCP ports for HTTP and HTTPS traffic. And the protected application is listening on another set of ports like 80 and 8080. Now, if we'll take a look at the corresponding service for the application and try to do get service, put YAML. We can see that the service is listening on port 80 and 8080, but the target port is set on the TCP port used by the alarm WAF container. So the requests hitting the application are first hitting the container with providing protection, and after that, from the application, the system is safe requests forwarded to the application. And I can switch back to the browser and back to the example of Terraform code and just demonstrate you. It's a Terraform demo application, vulnerable web service, and here is an example how using Terraform you can run Kubernetes deployment for the application with a definition of 2 containers. Here, for example, you can see definition for Alarm sidecar containers with different attributes and configurations, and more detailed NGINX configuration is passed as a file through a mounted volume. And here below is a definition of application container itself. Information about malicious attacks detected by the system are shipped to the Alarm Cloud, where you can see, this is an example of our console, and if you go to events section, you'll be able to see information about blocked malicious requests, and we provide a lot of information for you to have a pretty good understanding about what's going on with your security landscape. And you can analyze individual requests, malicious requests, in order to see what type of attack it was. In this case, it's a SQL injection attack. What was the source of the attack? And if we can associate the IP address with a known data center, in this case, like with GCP, we'll also add a label with corresponding data center. What was the target of the attack? Domain name, port, specific URL. We know the return code provided by the application. In this case, WAF running in monitoring mode in the demo environment. So you can see that the request was detected but not actually blocked on purpose. And also because we provide full protection and automatic parsing for API requests, and in this case it was a JSON body, we're able to dynamically parse the request and figure out where specifically in the request we see malicious payload. And it was done without providing any schema for the system. So this is our seamless approach for API protection. You're welcome to go to alarm.com website, and if you'd like to get more information about the product, you can read from our documentation pages, or you can sign up for a product demo, a more detailed product demo. Thank you, Stepan. Stepan?
All right, well, while he's hopefully reconnecting, just a quick reminder, we are going to get into question and answer here in a minute. I think Stepan is trying to rejoin here. There he is. Hey, Stepan.
Hey.
All right, you're back. All right, I'll let you get back to your presentation.
I don't know. It's actually, I think it's time for question and answers.
Okay. All right, well, then, hey, I have good timing then, I guess. Let's go ahead and get to any questions that have come in. But just a quick reminder, we have about 3 or 4 minutes for questions. So if you do have a question, please go ahead and use that Q&A tab and get your question on in. Our first question for you. Do you guys support protection for gRPC and GraphQL APIs?
Yeah. So there was a slide in the deck, so like we'll share it after. But we definitely support all the gRPC and GraphQL APIs. We initially supported everything that is based like on SOAP and REST, and we implemented a very fast parsers for all the JSON and XMLs to make sure that we actually have a almost zero latency in your traffic flow. And for one of the large accounts here in Silicon Valley, we implement gRPC support so that you can actually protect all those endpoints that are exposed, but also microservices that communicate with each other using the gRPC. And obviously, GraphQL is a big thing, and getting more and more insights of what is going on. And I see the Victor is showing the demo. So this is an example of gRPC. Do you want to talk about it, Victor? I think I can tell everything. So you can see there's that there was a post of the request and there was a gRPC. So as all of you know, the gRPC uses the protobuf format to store all the data and transmit there. So we don't need schema as well, even though for the protobuf you usually need a schema. So we automatically identify the whole thing. And in this particular case, we identify this union plus select. Obviously, SQL injection payload are coming against your application, and we obviously support it. For the GraphQL, by the way, like we're great fans of the GraphQL, and we wrote a lot of articles on the GraphQL production, so feel free to go to blogwall.com and
Awesome.
read some of our research.
Awesome. All right, great. Let's see. Next question. Can I send all of the events from WallArm to Splunk or Elastic?
Yeah, that's a good question. So, yeah, I mentioned how to set up the ElasticAlert for our open source solutions, but one of the things that we provide out of the box is basically integration with anything that you have. It can be SIEMs, it can be SOARs. By SOAR, I mean the incident response systems, any kind of DevOps tools like PagerDuty or OpsGenie, and basically we support webhooks. So you can have everything. Whatever you have, like you can use webhooks to set up integrations and get alerts, notifications about the attacks, incidents, vulnerabilities from your system. So like it's out there. And the API is also available, so you can get all the data from the API. API is available to manage WallArm, but it's also available to get all the data out of there. So yes, you can send everything to Splunk and Elastic, and there are out-of-the-box integrations for everything there.
All right, great. I think we have time for one, maybe two more questions. Well, probably just one. How do you detect false alarms in DDoS? Is there a configurable threshold with respect to the number of hits to detect false alarms?
Yeah, false positives. So like it's and I see that Victor is showing the example of Splunk integrations when we have it, like to get into the previous question. So false positives is a big topic, and we can talk a lot about that, like how to make sure that we can provide the protection with a high accuracy, and to any specific attack, there are like their own techniques how to minimize false positives, like SQL injections, for instance. We implemented the almost like not almost, but like entirely signature-less approach is called leap detection. It's open source, by the way. You can go to leap detection library and take a look what is the way to that. But the idea is that we grammatically describe what is SQL injection, and in this particular case, we can almost avoid any false positive for the SQL injection attacks. For DDoS, like it's also a different approach for that, but we basically have adaptive thresholds that are set up specifically to your application and apps, like based on what we see during some particular time frame. But feel free to reach out to us, and we'll talk more about that, because it's a big topic. Can't really answer.
Yeah, that may even be a webinar into itself, right?
Maybe.
All right, great. Well, we are 2 minutes to the top of the hour, so unfortunately that is all the time that we have for question and answer period. Manjunath, who did submit that question, I'm sure the folks from WallArm will be getting in touch with you offline to maybe speak with you more about your question. And I do want to thank everybody who did submit questions. There were some really good ones there, so thank you so much. Also, a quick reminder that today's event has been recorded, so if you missed any or all of it, Or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, real quick, before we close things out, we did mention that we would be doing a drawing for 4 $25 Amazon gift cards. So with that, let's go ahead and do the drawing here. Our first winner today is Glenn H. Congratulations, Glenn. Second winner today is Maria G. Congratulations, Maria. Third winner today is Joel H. Congratulations, Joel. And our final winner today is Judy K. Congratulations, Judy. We'll be following up with all 4 of you via email to get your Amazon gift card over to you, so please check your inbox. If you don't see anything in your inbox, please check your spam folder. Stepan and Victor, thank you both for a great presentation today. Good stuff all the way around. Fascinating technology. So thanks so much for your information and your insight. Really appreciate it.
Thanks, Charlene.
I also want to thank the audience today for joining me. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.
Stay safe.